All right, so for page 31, I'm going to talk about how to graph a polynomial function. So there are 4 steps that we're going to go through to graph a polynomial function. The last step is to draw the graph. So the first 3 are going to give us information in order to get a good graph. Now a polynomial function is a smooth continuous curve. There's no jumps, vertical asymptotes, holes, corners. It's just a nice smooth continuous curve. We did an exploration on this in class where we looked at a lot of different polynomials and they were just curvy lines. So we're going to try to get more details about the curvy line and graph it accurately using these steps. So the first one is apply the leading coefficient test to find end behavior. End behavior means what is your graph looking like at the end? And there are 4 possibilities. Your graph, this is a very simple polynomial, but it could have both of the arrows pointing up, and we call that up, up. It could have both of the arrows pointing down. We call that down, down. It's another possibility. It could be where they're pointing different directions. So we call, if it's down first and then up second, we call that down, up. And if it's up first and down second, we call that up, down. So these are the 4 possibilities. Again, these are really simple. We might have a lot more like curves and weird stuff in here, but in the end, the arrows either have to both point up, they have to both point down, or have one of each. So here's what we're going to look for. The leading coefficient test says look at the term with the largest exponent. Okay, all the other terms don't matter. Depending on what this coefficient is and what this number is, will tell you the end behavior. If this is positive, it could be up, up. If this is negative, it could be down, down. Okay, how do you know? Well, both of these, the n or the exponent must be even. So if you have an even exponent, they'll match up, up, or down, down. And what will tell you up, up, or down, down if it's an even exponent is if it's positive or negative. So next we'll look at odd exponents. So if these exponents are odd, then we'll have something like this. How do you know which one? Well, it's down, up if this is positive, and it's up, down if this is negative. So it really gives you a lot of information about how the end of the graph looks. How the middle looks, you can find by finding the zeros. The zeros are the x-intercepts. And x-intercepts we've talked about quite a bit. What you'll do is you'll plug in 0 for y and factor. You've set each factor equal to 0. Solve those. And last is going to be check the multiplicity. Here's the deal. With multiplicities, it's going to affect how your x-intercept is graphed. So I'm just going to do a quick example to talk you through that. If you factor it and it looks something like this. So here it is factored. If we factor and set each factor to 0 and solve, this would give you an x-intercept of positive 1. This would give you an x-intercept of negative 3. The multiplicities are the exponents. They're how many times that 0 occurs. Here, because it's squared, it has an even multiplicity because of this exponent. So it has an even multiplicity. An even multiplicity means it touches the x-axis. It doesn't cut through the x-axis like a regular x-intercept, it just goes down and touches it. Here, if that number is odd, it's called an odd multiplicity, and then it will cross the x-axis. So multiplicity, even or odd, touch or cross. Last, we're going to plot a few additional points to give us just some more detail in your graph. And what I'm looking for is for you to find points to the left and right of each zero. That should give you enough information in order to graph. The graph, again, will be a smooth, continuous curve. Something like this, a smooth, continuous curve.